Hey, welcome back to Math with Patrick. Today is June 3rd, and we're solving problem number 154 from this Daily Epsilon calendar. And looks like for today, we need to show why this blue area right here is equal to 3, which is today's date. So for starters, I see two triangles. I see what I think are two squares. It doesn't really tell us that they're squares, but I think we need to assume that they are to even begin to solve the problem. So let's assume that these are squares. And so all of these lengths are going to be the same. It looks like that'll be a 3 and a 3. And then this bigger square, let's kind of draw those same 90-degree markers. I'll use 2 tick marks here to just kind of denote that all of these are the same length and different from the ones that I use 1 tick mark for. And all of those lengths should be 4s. Okay. So what this did offer me is some lengths for the triangle that we're trying to solve. And what's kind of cool is, we need lengths on a triangle to solve for its area. Usually the area of a triangle is just 1/2 times base times height. But these lengths, the base and the height, they do need to be orthogonal or like 90 degrees to each other. And at least in this triangle, I'm not quite sure. They just don't look like they're 90 degrees to each other. Like if I wanted to find the area of this triangle, maybe I'd use like the 4 as the base. And then I need to know this distance right here as my height in order to plug it into this equation. So, if I guess we knew something about this angle right here, I could use a little bit of trigonometry. I could do like sine of theta. That is equal to opposite over hypotenuse. Maybe we'll just put an x here for this opposite side I don't know. And so it would be x over 3. And then if I wanted to solve for this x, for like the height of the triangle, I could just multiply both sides of this equation by 3, and I get 3 sine theta equals x. So this x is the height of my triangle, and I think it'll actually be important to use this formula instead, just because I don't really see any right triangles anywhere. Like this triangle doesn't have any right angles, nor does the other one. And so I think we'll need to kind of dip into angles on this one. So I know it says 3 sine theta right here. I think I'll just call it A sine theta for now. And I'll just remember that like A and B are going to be some side lengths, and then theta is going to be some kind of angle in the triangle. So now that we kind of both know we need to start investigating the angles, how about let's take a look at what's going on in the center of the diagram. I see that there are 4 angles. There's, 2 squares and the 2 triangles. There's 4 angles in the middle that all join to basically make a full circle. And so if I add, let's say theta 1, that's going to be this angle right here, theta 1. If we add theta 1 and theta 2 together with both of those 90-degree angles, we are going to create a full circle, or like 360 degrees. And then subtracting away those two 90s, we can see that theta 1 and theta 2 add up to 180 degrees, or they're supplementary. And I think this will be pretty useful. So like if I wanted to find the area of the blue triangle, like x, that's the area, I would do 1/2 times 3 times 4, and then times sine of theta 1, right? Because that's the angle on the inside of that triangle. And so basically, all I need to do is learn a little bit about that theta angle. And I think I'll be able to figure out something about that angle by investigating that like long obtuse triangle. I could do the same thing, right? The area of that long obtuse triangle is just 3. That's what it kind of tells me here. And 3 is going to be equal to 1/2 times, and then I think the formula is going to be pretty much the same. 3 times 4 times sine of theta 2. Let me just double check that that makes sense. I'll redraw the triangle. Here's the 3, here's the 4. And then theta 2 is this angle right here. And how about the 4 will be my base, and then this unknown side will be my height. And then I guess I'm running into a little bit of an issue here because it's this angle that I actually want, right? Because if I do, I'll call this one, I don't know, theta 3 for a sec, theta 3. If I do sine of theta 3, that's going to be opposite, which I'll call h for now, h for height, opposite over hypotenuse. And so I will get this like 3 sine theta 3 equals height. And so like here I'm basically just like rewriting the exact same thing that I did earlier, where I'm just trying to find the area of the triangle using the sine function. But I guess for this problem, I really wanted to use this theta 2 because that's the angle in the diagram. And then here I had to like kind of do something different and produce like yet another third angle. Although, wait a second, these are supplementary to each other, right? Because they make a linear pair, they make a line together. And so that must mean that theta 3 plus theta 2 is 180 degrees. And also we proved that theta 1 and theta 2 are also supplementary. And so from this little find, I think I can say that theta 3 is equal to theta 1. Like these angles are the exact same. And so this height that I need to find the area of this like long obtuse triangle is actually, it wasn't this theta 2, it was theta 3. This was the angle that I needed right here to use the sine function on to find the area of the triangle. But then I think basically I'm kind of realizing that this theta 3 is the same thing as this theta 1. And since these two angles are equal to each other, so these two angles are equal, therefore that must mean that x and 3 are equal to each other. Or in other words, since these angles are like really, they have a lot in common between the two triangles, therefore the area of those two triangles are the same. And I think that probably about does it. Because here, I'll even draw in the diagram that theta 3 is going to be this guy right there. And then since that theta 3 is precisely the value that lets me get an area of 3 for another triangle, and because theta 3 and theta 1 are the same angle, then when I plug that into here, I will just get the number 3 again. And so that basically does it. X is 3. These two triangles have the same area. I think that's all. All right. Kind of an interesting way to do it, but I'd say we're all done. Thanks for coming along. I'll see you tomorrow. Bye-bye.